The evolution of clocks, how humanity learned to measure time. Imagine a world without clocks. No schedules, no deadlines, and no way to track time accurately. But humans have always needed to measure time, whether for farming, navigation, or daily life. The story of timekeeping is a journey of remarkable inventions, from simple shadows cast by the sun to the precise atomic clocks of today. Hello everyone, welcome to our channel Evolution of Ideas. In this documentary, we will explore how ancient people measured time, how timekeeping evolved, and the brilliant minds who shaped our understanding of time. Chapter 1, The Earliest Timekeepers, Nature's Clocks. Long before mechanical clocks, humans relied on natural timekeepers like the sun, moon, and stars. The sun as the first clock. Ancient civilizations observed the movement of the sun to estimate time. The earliest method of tracking time was simply watching the position of the sun in the sky. Sundials, around 1500 BCE, were one of the first human-made timekeeping devices, used by the Egyptians and Babylonians. These devices used a gnomon, a stick or pillar, that cast a shadow on a marked surface. The shadow's movement indicated the time of day. 1.2 Tracking time at night, the moon and stars. Sundials were useless at night, so ancient people turned to the moon and stars. The Babylonians and Greeks divided the night sky into 12 parts, using star constellations as reference points. The water clock, or clepsydra, was invented by the Egyptians around 1600 BCE as a way to measure time more consistently. It worked by allowing water to drip through a small hole at a steady rate, marking time as it emptied. The concept of 24 hours, minutes and seconds. 1. The Egyptian origin of 24 hours, around 3000 BCE. The ancient Egyptians were among the first to divide the day into 24 parts, inspired by the movement of celestial bodies. They used sundials during the day to divide daylight into 12 equal parts, which became the 12-hour day. At night, they observed 12 specific stars moving across the sky, marking 12 night hours. Thus, 12 hours for day plus 12 hours for night equals 24-hour system. However, these hours were not fixed in length. Summer daytime hours were longer than winter daytime hours. 2. The Babylonian influence, base 60 system. The Babylonians, around 2000 BCE, inherited this system but refined it with their base 60, sexagesimal, counting system. This is why 60 minutes per hour. 60 seconds per minute. This division was later used by Greek astronomers to measure time more precisely. 3. Greek and Roman standardization. The Greeks, especially the famous Hipparchus, 2nd century BCE, proposed dividing the day into equal 24 hours based on the Earth's rotation. The Romans later popularized this idea. By the time of mechanical clocks, 14th century CE, the 24-hour day with fixed-length hours became standard worldwide. The 24-hour day originated with the Egyptians' 12-hour system, was refined by the Babylonians, and standardized by the Greeks and Romans. Today, it remains a fundamental part of how we track time globally. Chapter 2, The Mechanical Revolution, Gears and Precision. As societies advanced, they needed more precise ways to measure time. Mechanical clocks became the next major leap. First mechanical clocks, 13th to 14th century CE. The first true mechanical clocks appeared in medieval Europe around 1275 to 1300 CE. These early clocks used weights and gears to regulate time and were placed in church towers to help communities track time. The oldest surviving mechanical clock still in operation is in Salisbury Cathedral, UK, built in 1386. Galileo and the pendulum, 17th century CE. The biggest breakthrough in timekeeping came in the 1600s, thanks to Galileo Galilei. Around 1583, Galileo observed that a pendulum swings at a consistent rate, no matter how wide the swing. His discovery led to the invention of the pendulum clock by Christian Huygens in 1656. Huygens' clock was accurate to within 10 seconds per day, a major improvement over older mechanical clocks. Chapter 3, The Age of Precision, Pocket Watches to Quartz Clocks. 1. The birth of pocket watches, 16th century CE. By the 1500s, clockmaking had become more advanced, leading to the invention of portable timepieces. The first pocket watches appeared in Germany in the 16th century. They were powered by mainsprings, making them more compact. Peter Henlein, a German locksmith, is often credited with creating some of the earliest portable clocks. The marine chronometer, solving a global problem, 18th century CE. Before the 1700s, sailors struggled to measure time accurately at sea, leading to navigation errors. In 1761, English clockmaker John Harrison developed the marine chronometer, which could keep accurate time even on rough seas. This invention revolutionized navigation and helped sailors determine longitude, changing maritime history forever. Chapter 4, The Modern Age, Quartz and Atomic Timekeeping. 1. The Quartz Revolution, 20th century CE. The biggest leap in timekeeping came in 1927, when Warren Marrison invented the quartz clock. Quartz clocks use electricity and vibrating quartz crystals to measure time accurately to a fraction of a second per day. This led to the development of wristwatches, making precise timekeeping accessible to everyone. 4.2 Atomic clocks, the ultimate precision, 20th to 21st century CE. In 1949, the first atomic clock was built. These clocks measure time using the vibrations of atoms, specifically cesium atoms, which oscillate at an incredibly stable frequency. Today, atomic clocks are accurate to 1 second in millions of years and are used in GPS, space exploration, and scientific research. How modern watches work, a breakdown of timekeeping technology. Modern watches have evolved from ancient sundials and mechanical clocks to highly precise electronic and smart devices. Today, there are 3 main types of watches: mechanical, quartz, and smartwatches. Each works differently but serves the same purpose: keeping accurate time. 1. Mechanical watches, powered by gears and springs. Mechanical watches are the oldest type of modern watch and work without batteries. Instead, they rely on a complex system of gears, springs, and levers. How it works. 1. Mainspring. The user winds the watch manually, or through wrist movement in an automatic watch, which tightens the mainspring. 2. Gear train. The mainspring slowly uncoils, transferring energy through a series of gears that regulate speed. 3. Escapement and balance wheel. The escapement controls the release of energy, making the balance wheel tick back and forth at a precise rate, usually 21,600 to 28,800 beats per hour. 4. Hands movement. The controlled energy moves the hour, minute, and second hands. Why people love mechanical watches. Luxury and craftsmanship, Rolex, Omega, Patek Philippe. No battery needed, just regular winding. Smooth sweeping second hand, unlike the tick-tick of quartz watches. 2. Quartz watches, the power of electricity and crystals. Quartz watches are the most common and affordable type of watch. They are extremely accurate and require little maintenance. How it works. 1. Battery. A small button cell battery powers the watch. 2. Quartz crystal oscillator. The battery sends electricity to a tiny quartz crystal, making it vibrate at a precise frequency of 32,768 times per second. 3. Circuit and stepper motor. A circuit counts these vibrations and sends signals to a tiny motor, which moves the watch hands. Why quartz watches are popular. Highly accurate, loses only a few seconds per month. Low maintenance, battery lasts for years. Affordable and widely available, Casio, Seiko, Timex. 3. Smartwatches, mini computers on your wrist. Smartwatches go beyond just telling time. They combine electronics, sensors, and wireless communication for features like fitness tracking, calls, and notifications. How it works. 1. Microprocessor and sensors. A tiny computer chip calculates time digitally and runs apps. Sensors track movement, heart rate, and more. 2. Display technology, uses LCD or OLED screens instead of hands. 3. Rechargeable battery, powers the device for 1 to 7 days, depending on usage. 4. Wireless connectivity, connects to Bluetooth, Wi-Fi, or LTE for phone syncing. Why smartwatches are gaining popularity. More than just time, fitness tracking, GPS, calls, etc. Customizable, digital faces, app integrations. Convenience, replaces traditional watches for many users. From ancient gears to vibrating quartz and modern smart technology, watches have transformed how humans track time. Whether you prefer the classic craftsmanship of mechanical watches, the precision of quartz, or the high-tech convenience of smartwatches, every watch today is a marvel of human engineering. Conclusion: the future of timekeeping. Humanity's journey of timekeeping has gone from shadows on the ground to atomic precision. Today, scientists are working on optical clocks, which may replace atomic clocks in the future with even more precision. As technology advances, the way we measure time will continue to evolve, but one thing remains constant: our quest for accuracy in understanding time itself. From ancient sundials to modern atomic clocks, timekeeping has shaped human civilization. It allowed us to navigate the seas, build empires, and explore space. What's next? Could we one day measure time beyond the atomic level? The future of timekeeping is still unwritten. Subscribe to Evolution of Ideas to explore more stories of human innovation.